Hello Algebra 2 students. So this video is a continuation of the previous one where we went over the theory for how to find inverses, what a matrix inverse is in the first place, and the idea of how to solve a basic matrix equation. So what we're going to do now is basically one of the most important things I think you've probably ever done in math so far. Hopefully also one of the most interesting. We're going to use a matrix equation to describe each one of these systems of equations, and of course we're going to solve it to find the solution to the system. So first I have a new symbol to introduce to you. So I'm going to argue that this system of equations right here, this simultaneous set of equations, is exactly equivalent. Now this symbol means several things, but in Algebra 2 we should realize that it means equivalent. You might have also seen it in geometry as if and only if. So the solution to this is true if and only if, or equivalently, if you have the solution to this matrix equation. So what I want to do is first peel off the coefficients, in other words, the things attached to the variables. So in this case I have 1 and 1, and 2 and 1, and over here I have 8 and 1. So you might want to try to guess what goes in this variable matrix container, but in this case it's x and y. So I claimed that this system and this matrix equation represent exactly the same thing. Why? Think about it. Do your matrix multiplication dance. 1x plus 1y is 8. That's exactly what that says right there. 2x slide plus 1y equals 1. That's exactly what you have there. So I think it's pretty easy to see just with the matrix multiplication, these are exactly the same thing. So in other words, if we can find the answer to this, it's going to be the same answer to our system of equations. So this provides us a new tool to find the solutions to systems. Okay, so remembering what we did in the last video, we could call this matrix A, this has the variables in it, so I'll say multiplied by matrix X equals matrix B. How do you solve that? Well, to get rid of A, we just learned you use the inverse of A, and you make sure that you apply it on the left side on both sides. This cancels out to the identity matrix, so you're just left with X. So over here you just need A inverse times B. So all I need to do to solve this problem is find A inverse and multiply it by B. I'm going to do this example by hand, and then we'll do the larger example with our calculator. For your assignment, you should be doing the 2x2s by hand, all the steps, all the parts. You can check it with your calculator if you like. You should do the 3x3s or anything larger, like the 4x4, with your calculator. So I'm going to erase some of this business right here and just leave my ultimate answer. So I need A inverse. I've already got B. So let's remember what A inverse is. If this is A, then A inverse is equal to 1 over the determinant of A times a rearrangement of A. Remember, you take these and you switch them. In this case, not a lot's going to happen. And you take these, you leave them in place, and you negate them. So I just need the determinant of A. So what is the determinant? Do some scratch work if you like. Is 1, is 2, and subtract. So I have 1 minus 2, which is negative 1. All right, so I need to copy and paste this rearrangement. Try to simplify this. On many problems you want to do that. Sometimes you might have to copy dot flip, something like that if you have a fraction on the bottom. Here I've just got a nice friendly negative 1 as my scalar that I need to multiply through the matrix in order to get the inverse. So negative 1 times 1 is negative 1, and so forth. And that is A inverse. Now remember, to solve our matrix equation, we've got to take A inverse and multiply it by B. So the solution to our system of equations is going to be A inverse times b. Let's see what we get when we do our slide computation. If you wanted to check your dimensions here, you of course could. This is a 2 by 2, 2 rows, 1 column. Yes, I can do it, and I get a 2 row by 1 column thing. Okay, I'm just going to do this one in my head. -8 slide plus 1. What's -8 plus 1? I think that's -7. Sweet. And 16 minus 1 is 15. That's x. That's y. So let's write down our answer here, and let's check it with our calculator. -7 and 15. I think we should check this with another method since we're at it. Let's go to our calculator and check it by graphing. So I'm going to go to y equals, clear out anything that I have, and I'm going to put in my system. So if you look up over there, you can see that we can put in y equals for both. So if I go 8 minus x, that'll solve for y in the first one. If I subtract 2x in the second one and go 1 minus 2x, that's the second line. Let's graph this guy, zoom 6. So here's my 2 lines. It's clear that we're going to have a solution somewhere up here. That means I need to raise the maximum. So I'm going to go to my window. I want to raise the vertical, so y max instead of 10, how about I go 20? And I'm just going to make this a little bit back farther as well, just for clarity. You definitely want to make sure you're playing with your calculator's window and all that good stuff in Algebra 2. You'll be expected to know it very easily in other classes and this one. So let's calculate the intersection. Second, calculate intersect. And now I'm going to go on the left for my first curve, on the right for my second curve, and I'll guess. And you can see -7, 15 is the solution we got with the matrix method. Let's do this on one more problem before we quit for today. Let me fix my focus just a bit. There we go. So I have a nice 3 by 3. This one we're going to have our calculator do more of the work. So first, have a look at the 3 by 3 and tell me, is there anything different about it besides the fact that there's 3 variables, x, y, and z? Well, you can see on this one the x's kind of line up, but that's not fixed, right? I think we need to switch around some things in this middle equation. So you can either write it all over again or you can do some erasing. I think I'm going to do some erasing. 2x needs to be there, -3y needs to be there. These just need to switch positions. So let's switch them. This is something you've got to watch out for when you're solving systems, always. So make sure you're aware of it. I need z's here, that's a z. I need numbers here, constants. I think we need to switch these guys as well. This time we've got to go over the equals, so you need to add z to this side and subtract 16 to that side. So I think we'll get positive z here and -16 here. And now I'm ready to write my matrix equation equivalent. And this is what I want to see on the exam and on your assignments. What is equivalent to that? Well, I need a matrix A, nice 3 by 3 this time. I need a matrix X, and that's going to be equal to a matrix B. Peeling off my coefficients, I get 5, -2, -3, 2, -3, 1, 3, 4, -2, -7, -16, and 7, and of course my target x, y, and z. You might want to quickly check when you're first learning this idea to see if that actually is equivalent by doing your little dance. 5x minus 2y minus 3z is -7. That's what that says, and so forth for the other two. Remembering what this all meant, this we call our matrix A of constants. This was matrix X. They're multiplied together, and we get matrix B. So to solve, you go A inverse B on this side to cancel, A inverse B on that side. Our A inverse on that side as well. Okay, let's have our calculator do all the work for us this time. So I'm going to quit. I'm going to go to my matrix menu. I'm going to go over to edit. And you can see I already have this problem loaded, so I'm going to cheat and get rid of it. Just give me a moment. So going to my matrix menu, go over to edit. We want a 3 by 3 for matrix A. So load yours up. 5, negative 2, negative 3, 2, negative 3 and 1, 3, 4, and negative 2. Do a quick check. I'd always double check real quick that you didn't make a typo. It's very easy to do. I'm good. I'm going to quit. Go back to my matrix menu, back to edit, and go to B. B has 3 rows and 1 column. If you forget, play around with it. Got negative 7 already. Negative 16 goes here, and 7 goes here. Quit. And now we're just going to tell our calculator to do A inverse B. So go grab matrix A. I'm going to grab it instead of editing it. Now I just need to know where's the button for the inverse calculation. You don't want to raise it to the -1 power. This is your calculator screen. The matrix menu is right here, and that is actually called -1. The reason is because they expect high school students to use that matrix operation the most. That's why that button gets the honor of being called the inverse button. So press that button, and we want to multiply by matrix B. So let's go grab it. And there you go. There's the solution. These 3 planes cross at the point -3 to -4, meaning that these 3 planes are consistent and independent of one another. I hope you found that lesson interesting in bringing together a variety of ideas we've been playing around with for a couple weeks now. I'll see you next time.